So the past couple of days we've been attempting to solve sides of a right triangle, and we've been mostly solving for these sides using the trig functions, the sine, cosine, tangent, etc. So today we're still going to be solving for sides of right triangles, but we're not going to use the trig functions in this lesson. So in this lesson we're going to focus on two very specific triangles, two right triangles that we call special triangles. And these are the 45-45 triangle and the 30-60 triangle. Now, if you don't have what I've got written right here copied down in your notes somewhere, please go ahead and pause the video and get these written down, because we will be referencing them quite a bit, and you will need these when you go to do your problems. So, in these two special triangles, there are very explicit relationships among the sides. And long story short, the reason why these relationships exist is because when triangles have the same angles, they are similar, which means their sides are going to be proportional. And that's why these relationships that we're going to use always hold true in these very specific special triangles. So let's start with the 45-45 triangle. So what we know in these triangles is that the two shorter sides, the legs as we call them, they're going to be the same length. So I'm just calling this x and x. And so these are going to be the same length always. And our hypotenuse is always going to be whatever that length is times square root of 2. So that's the gist of the relationship for 45-45 triangles. When we get to 30-60, the relationships are a little bit more involved, slightly more complicated, though not much more so. So when we get to the 30-60 triangles, their relationship works like this. We've got the shorter side. Our shorter side is the one across from the 30-degree angle. If we know that length, here's what else we know. We know that the hypotenuse is twice that length. And we also know that the other leg is that length times square root of 3. So if we know the shorter leg, we can fairly easily figure out these other two lengths using these corresponding relationships here. The hypotenuse is twice that length. The other leg is that length times square root of 3. So that's how the relationship in the 30-60 degree triangle works if we know the shorter side, the one across from the 30-degree angle. But sometimes we're not given the shorter side. Sometimes we are given the hypotenuse. And when that is the case, so notice that we are still in the same triangle. We still have a 30-60 degree triangle here, but I've rewritten the relationships in terms of the hypotenuse. So if we know the hypotenuse, here's how we can figure out those other two side lengths. So if we know the hypotenuse, the shorter side is going to be exactly half of that hypotenuse. To figure out the other leg, the side across from the 60-degree angle, we take that hypotenuse length and we multiply it by square root of 3 over 2. So if we know the hypotenuse, that's all well and good. We can use it to find these other two sides. The shorter side, all we have to do is take that hypotenuse and divide it by 2, or multiply by 1/2, if you will. The other side, we have to multiply by square root of 3 over 2.